Hello everyone, many thanks for joining this first webinar in a series on flood and drought management. This first one is all about the use of satellite data for flood and drought management, and we're going to be covering some of the most interesting tools as a start. My name is Gareth James Lloyd and I'm a Senior Advisor at the UNEP-DHI Partnership, a United Nations Environment Collaboration Centre in the area of freshwater and environment. I'm going to be your facilitator on this webinar today, and Maija Bertule is going to be providing some technical support for me. This webinar series is a collaboration involving a number of partners, including the Global Environment Facility, UNEP, IWA and DHI, and along the way we're going to be having other valued partners making additional contributions. The overall aim of this series is going to be to give you an insight into the role that innovative approaches can play in addressing flood and drought management issues, and in the series you can expect to hear from us a little bit about cutting-edge tools and methods for applying them at different scales. And we're going to be pulling in some real-life case studies along the way that demonstrate both what works and what doesn't work, as well as how some of the most challenging situations can be addressed. Just before moving on to the agenda, I'd like to briefly give you the backstory to this webinar series. If I can, yeah, there we go. Much of what you're going to be hearing about is either based on or inspired by a quite exciting ongoing project that hides behind quite a mundane name. The Flood and Drought Management Tools Project is the name, but please don't let that put you off. The cool thing about the work on this project is that all the tools that are being developed are being made for generic applicability, and they're going to be disseminated and made widely available for free. And what is being developed is based on specific input from stakeholders in the Volta Basin in West Africa, the Chao Phraya River in Thailand, and Lake Victoria in East Africa, as well as other experts will be providing inputs. If you want to learn more about the project, please check out this link after we're done here, and kindly note not to use the www prefix. So on the agenda today we have Oluf Jessen and Bertrand Richaud to present. Oluf is going to tell us how satellite data can be applied in flood and drought management situations. And following this, Bertrand is going to give us a live demo of a working data portal. I should probably just add that the main reason for starting here is that in terms of flood and drought management, generating data and converting it to usable information is often regarded as a fundamental first step in taking preventative action. As you can see, each presentation is going to take about 10 to 15 minutes, and time permitting, the plan is to allow for 1 or 2 questions immediately after each presentation, with some additional questions at the end. And to you, the participants, in the panel on the right of your screen, you should be able to see a box for submitting questions. So, yeah, if you open that up or expand it, you can type in there and send it in to us, and we'll try to pick up on the most interesting and relevant of those along the way. So please feel free to make good use of that. I also need to remember to tell you that all presentation slides and webinar recordings in the series are going to be made publicly available on YouTube and can also be accessed through the UNEP-DHI.org website within the next few days. And not long after that, you'll be able to access them via the project website link that I included on my second slide. So without further ado, I would like to ask Maija to pass control over to Oluf so he can begin. Oluf, if you could please unmute your mic whenever you're ready, and I'll let you know when we can see your screen. Yep, that's good. I can see your mouse, and I think I can hear you. So please feel free to start whenever you're ready.
Thank you, Gareth. My name is Oluf Jessen. I'm from the Water Resource Department at DHI in Denmark, and I'm also the project manager of the Floods and Drought Management Tools project, which Garrett introduced. I'm very happy to start this webinar series with a very brief introduction onto satellite and model data and how we have intended to use this within floods and droughts management within the UNEP project. I will in this presentation give a very brief introduction to how we are using the satellite and model data for flood and drought assessment, and I will also give the background to the data and information portal that my colleague Bertrand will give a live demo of just after this presentation. When looking at planning or decision making, and especially how to improve this, then data availability and data quality is often one of the key concerns. And in many locations, then the availability of a basic set of data for planning is often one of the limitations or boundary conditions for a planning process. So very early on in this project, we looked at how could we apply satellite data and model data to support ground stations within a planning or decision process. So the objective was basically to develop an information system enabling a basic set of data for planning at any transboundary basin on the globe. I should just mention that I'm mentioning transboundary basins because it's a project which is funded by GEF, so the focus is on transboundary basins, but the concept and the data and information system which we have developed can basically be applied on any basin or catchment on the globe. So the main focus has been to support planning at a global scale, so support planning within any transboundary basin on the globe, and make data with specific focus on spatial data and near real-time data, make those available for stakeholders and decision makers. All the data that we are looking at is freely available, and after we are doing a QA and processing of the data, we convert them into open formats as .NET-CDF files or text files. To support the use of model and satellite based data in planning, then we have developed an automated process which actually runs on a daily basis. So every night we are looking at different data servers to access if there's any available data. Then we download the latest data, we QA them, we reproject them, and we convert them into .NET-CDF formats to make them available. And then on top of this, we produce different derived products as indices, time series, and statistical measures. And then at the end, we make the data available on a public web-based data portal. And there's a screen dump of the data portal there, and you will get a live demo of this just after this presentation. As we are looking at data for floods and drought assessments, then we are looking at a wide range of data sources. We are looking at different types of climate data, a number of different types of rainfall products, temperature data, potential evapotranspiration data. And then we are also looking at forecast and climate change data. For the forecast data, we are using the NOAA global seasonal forecast model, which produces a 9 months rainfall forecast with 20 ensemble members. And we are at the moment using both the raw model data, but we are also making a bias corrected version available where we are downscaling the seasonal forecast based on historical trim data. Then we are also looking at climate change data from the Cortex project. For the drought assessment, we are looking at different vegetation and soil moisture data, and then we have some lakes and reservoir data available as well. We are at all time trying to expand data, and as the project will move along, then we will add more data to the data and information system. As we are looking at floods and drought assessments, then we need somehow to convert the data into a value where we can do assessments, and this is normally done through different types of indices, and which is where an index is basically a way to evaluate how the current value of a data source compares to what you would expect or what the historical values expresses. And this is normally done by using some different types of statistical measures as deviation, anomaly, percentile, or other types. When you convert data into indices, then you are able to categorize them and link them to impact categories, either for floods or drought. To the right of the screen, there's a table which is used in the US for different types of drought categories. And basically, these different types of drought categories are then linked to different ranges of values for specific indices. This also enables the users to look at impacted areas, and it also creates the basis for warnings or assessments related to floods and droughts. During this automated process, which we run every day, there we download and process or calculate a number of indices, and all of these are then made available on the data and information portal. The purpose of this data and information portal is basically to provide data and information for a planning and decision process. So it's a pure data and information provider for historical and real-time data and also forecast data. But the intention is also to provide data which can drive models or tools. It could be water resource models, it could be models looking at crop impact, it could be flood models. The third purpose is also to serve as a direct linkage to different types of planning tools, which we will develop as we move along in this project. And this could be to support different decision methods or planning processes as such. The last slide here is on what we are looking at, looking ahead, and we are looking to expand to have more focus on the climate forecast, as this is really critical for looking at floods and drought assessments in the coming weeks to months to season. So we are looking at applying a 2-week forecast, which would mainly be used for flood purposes. And then we are looking at different types of performance indices or skill scores to be applied to the data and information portal. And this will basically allow the user to access how well the climate forecast performs within the specific basin. Then we are also looking at evaluating different types of indices, so we will add other indices as we move along, and we will also have more focus on using combined indices where we combine a number of different data sources into one index, which can be used for drought or flood assessments. And then the aim is to, on top of this data and information portal, to develop different tools for drought and flood assessments, which will utilize the data within the data portal. And we will have a specific webinar on this early next year in February. Yes, this was a very brief introduction to what we are doing, and now if there's any questions, thank you.
Yeah, many thanks, Oluf. Can you hear me?
Yes, I can hear you very clearly.
Okay, great. Yeah, I have a couple of questions here for you that have come through. The first one is quite a general one. It is, how does this vary from what is currently being done? So what is new here? What is the cutting edge part? Could you say a few words about that, please?
There's a lot of different data portals available, which makes different types of satellite and model data available. What we are trying to do here is have a specific focus on the assessment part. So we are having additional focus on the climate forecast part, and we have linked up to different types of research projects to try and provide the best available climate forecast. And then we also have focus on making data available directly to models and different types of tools used for assessments afterwards. So a lot of focus on the application and assessment parts, not only the data part.
Okay, and a quick second question before we move on. Perhaps this question is more for Bertrand, but you're welcome to answer. I think both you and I have mentioned the word data probably 100 times already. How data reliant is this system? Do you need multiple data sources to get it to function, or how is it used?
Basically, how the system is used is that every night it looks at different data types, so then we download the global data and make those available for the user. And then it's actually up to, so the user will have the choice to select between a wide range of data, and then it's actually up to the user which data they want to work on their specific case. So the data portal in itself aims at providing a wide range of data for the user, and then it's up to them how they will further use them. But we will also provide tools which they can also use. But the use of the data is not limited from our side.
Okay, thanks. That was a useful answer. Maija, could I ask you to please pass over to Bertrand? And Bertrand, please unmute your mic and I'll let you know when we can hear you and see your screen. I think I can hear you.
Hello everyone, my name is Bertrand Richaud and I'm a water resources expert at DHI, and I have the pleasure to show you this portal that Oluf has just introduced in his presentation. So this is what we call here the Flood and Drought portal. It's a portal that has been developed as part of a project where the focus was transboundary basin. But of course, the methodology that we applied can be used elsewhere in the globe. And one of the first thing I want to show you is we have a portal which requires login access. So as a new user, you would have to register. And this can be done by clicking on the login and then register a new user link. When you click on this register button, you actually get access to a panel that lists all the continents, and for each continent you have the list of transboundary basin. All of them should actually be available here. Only some of them are already what we call in operational basin, and that means that we are already in our daily process retrieving data and processing data for these basins. So for example, the 3 pilot basin of the project have been already added, like the Volta basin. And if you do register as a new user to try the system, I would recommend to choose one of these operational basins so you can get access immediately to data. But you could select another basin, transboundary basin like Senegal basin, which does not appear as operational. There is no flag next to the name on the list here. Okay, but for the purpose of this presentation, I will log in as a user, and this demo will take place in the Volta basin. So you should soon see the map of the Volta basin on your screen. And again, what I'm presenting here is similar for other basin and other location in the world. When you first log in this system, you will be prompted to select your favorite product, favorite data. As Oluf mentioned, we have quite a wide range of data that we are retrieving from different sources, but maybe you would be interested only in some of them. So when you can also change these settings by going to the settings menu and access the full list of products that we have at the moment available, and activate the product you are interested in. So we have some rainfall products, we have some forecasts products, and then we have vegetation, soil water index, and climate change related products and other type down there. For the purpose of this demonstration, I have already selected the product I would like to show you, so I will simply update the settings here. So when this is done, the list on the left-hand side is now changed with the product I have selected. And I can activate a product by simply selecting it on the left menu. And now my product is displayed on the map. The map is really the center of this system, and that's why everything is happening will actually be done through the map. We now are viewing data trim, rainfall data for the last available time step. This is 21st of November 2016, so pretty much near real time. And I can go through different times using my data coverage bar at the bottom. By simply clicking, I will display another time step here. I could also select a specific time. For example, I want to show you what was the rainfall in the Volta Basin on the 23rd of June this year. So I can type in the text box, and you should soon see the rainfall pattern for that day. On the right-hand side, we have the legend that tells us, of course, what is the meaning and the scale that we are using for this product. So here we are viewing daily rainfall. Further to showing this data on the map, we also process it and provide it in a different format. For example, we can you can easily access to time series of this product by selecting the time series tool and clicking on the charts. In this case, we are going to view the area weighted rainfall for the entire Volta Basin. It is possible to use this chart to then zoom in into specific years or specific months, and of course this can be downloaded as a CSV file, so it can be used in other contexts if you like. But we are not providing only data for the whole basin, but also for sub-areas. You can, for example, select among the four main sub-basins in the Volta. We have added these four main basins on the map, and by simply clicking on them, you can select them and then view now the area weighted time series for this specific. We are now viewing the OT basin in the Volta Basin. Then we can also use this tool to select data for a specific location by clicking on the map or some specific key location in the basin. Another tool is actually the same product, but then resampled to monthly. For example, rainfall can be quite useful, not with the daily scale, but the monthly scale. So now you should see the monthly rainfall for the entire time periods and for the Volta Basin. On the top of the black line, you can also see a red line. This red line is the long-term mean. If you look at this long-term mean, you can see it is the same every year. So this is the long-term mean, so the monthly average rainfall. If we zoom into a specific year, so now we are viewing the last year available, we can see for a specific month, let's say last October, we can see we are the rainfall pattern, the rainfall in the Volta Basin is actually lower than the average. It is about 20 millimeter below the long-term mean. So this can be very easy way to compare rainfall pattern with long-term average. We are also providing a way to view this data in the form of a table. So this table is actually a summary of the entire data, so from the beginning to the end, and for every month we have some statistics here at the bottom the average, mean and max value for each month of the year, and similarly for each year in the data set. Lastly, we have another tool here that is available, is what we call the raster file. This is simply a way to download this data as a netcdf file. So in case you would like to use this data for creating your own maps, you could download it and import this into a GIS environment to create your own maps. Now I will move on to some other products that we have made available here that I would like to show you. We have a rainfall forecast. This is a seasonal forecast provided by NOAA. This is the Climate Forecast System version 2. Another nice tips I would like to show you is you can anytime click on the product and get some more information, including a link to the source. So we are referring to the original product portal, and you can read more, of course, there. Again, here you can view this data as a time series or also resample to monthly. For example, here I will select the monthly forecast for the entire Volta basin. So we can see this is an ensemble forecast, so it is not just one line, but here we have actually 20 members displayed. So it actually shows us the spread of the forecast. This can be also viewed in the different way as what we call an envelope plot, so to show how this spread evolves with the time. And here we have in gray zone the area between the 25th and the 75th percentile. And the line is the median of our ensemble. Then we have vegetation products. So we are linking to MODIS datasets. This MODIS dataset, the normalized difference vegetation index, tells us about the greenness of the vegetation. So again, this is similarly to the other products, can be viewed on the map or view also the time series for the whole basin or for a specific sub-area. We are also linking to Copernicus product, the soil water index, that tells us about the soil moisture of the root zone. So this is, you can see different resolution for each product. We are preserving the original resolution of the product, and it varies from product to product when it comes to spatial resolution, but also temporal resolution. This product is, for example, a 10 daily resolution product. We have temperature products also from MODIS. So similarly, we can view it on the map, also time series, and download it. Then I would like to show you another product which is slightly different. This is JSON water level of large water bodies. So it detects large water bodies in the basin. And for example, here we have the Volta basin, the Volta lake, sorry, where we can view the relative water level relative to a reference point. And we can, for example, see how this water level has evolved in the past month. On the top of this data product, we are as Oluf explained, processing this product to actually compute some drought indices. And this is what I want to show you here by displaying the SPI 1 month, the Standard Precipitation Index. This is an index that tells us how rainfall has been compared to normal in with relative numbers. So here, for example, we have highlighted some red and blue areas in the basin. Red areas shows lack of rainfall compared to normal. blue areas will actually show us that there's been more rainfall than normal. And again, this can be viewed as a time series, and for the specific index, values between are normally between -2 and +2. When we have negative values, it is because there is a lack of rainfall compared to normal. And when it is below -1, we normally we can say that it is start to point to a drought situation. We can see some time in, for example, 2015, where for the whole the average value for the Volta basin has been quite low, to -1.3. So these are the drought categories that Oluf introduced in this presentation. Another way to show this is as a column chart. So this is similar to a time series. We have the time scale in the x-axis, and we have in the y-axis the percentage of the basin that is under a specific drought category. For example, for these events that I mentioned previously in May 2015, we can see that the large part of the basin was under a drought category. So this can be a very way to highlight some events in the past. We are doing the same, for example, with vegetation data, where we are processing and we're able to show the deviation of the normalized different vegetation index compared to normal. So in the similar way, we can show this as column charts in time series like. So we can highlight also here, for example, that in June 2015, the vegetation has been impacted by the lack of rainfall that occurred a few months before. We are also working on some combined drought index. So for example, the vegetation health index that combines temperature and vegetation impacts. Further to this data and access to data which is useful to information decision maker, we are working on producing automated drought reports. So soon we will be able to provide to stakeholders an automated drought report that contain key information and that can be prepared on a regular basis with, for example, key tables and maps showing drought impacted areas. And then we are also working on some analysis tools which will be soon completed, and this tool will make use of the data to provide actually more information. We are working on hydrological models such as a rainfall runoff model and also crop water requirements. So the rainfall runoff model will make use directly of the climate data, but also climate forecast and climate change information to produce runoff information for specific catchments in the basin. And again, with the crop water requirements, similarly, climate information would be used both in historic, but also in the forecast, seasonal forecast and climate change information. I think that was it for my presentation. I look forward to the questions from the audience. Yes, thank you very much.
And thank you to you, Bertrand. Please don't run away yet. We do have some excellent questions, and thanks to everyone for sending them in. There's quite a lot. So in some instances, I think Bertrand has addressed them along the way, and for a few others, I'm going to try and paraphrase or group some of the question types together so we can all be sure to get some kind of response. A first question, when is this portal going to be available, Bertrand?
So right now, this portal is being developed for this specific project, and then we are making this available for the basin organization and all governmental organization in the transboundary basin. And we are still in the phase of testing some of these new tools that I mentioned, for example, the analysis tool and also producing reports, which should be available in the coming months. For users outside this transboundary basin, will probably take on the case-by-case basis, so most welcome to contact either me or Oluf, and we'll see what can be done.
Okay, great. And please could you tell me, is the portal going to be maintained long-term? Of course, the danger is things always end when the project ends. What's the plan at the moment?
Yes, that's a very good question, Garrett. Thank you. And of course, the intention is to keep this portal, of course, operational as long as possible. It actually doesn't require a lot of maintenance work when the process is automated, but we will look into this as we get closer to the end of this project, which is in 2018.
Right, and in relation to that, a question here: are data from commercial or free sources, or a combination?
Yes, the data is coming from free sources. We are always, as I showed you, referring to the original source of the data, and this is important. We are normally trying to keep the original resolution of the data, but then we are processing it in a form that can be used, for example, in the form of time series if it needs to be used in some models, or processing it just in an NCDF format. So all data is actually processed in the similar format, so that is to ease for example, producing maps with OneGIS environment.
Thank you. Oluf, could you please unmute your mic? I have a couple of questions I'd like to ask you.
Yeah, Garrett, go ahead.
Is it possible to influence the data types made available on the data portal?
Yes, that's also a very good question, Gerd. We are very interested in feedback and questions for this. So if anybody has some specific data types which are very relevant for drought or flood management, then we are very interested in looking into this. So the answer is yes.
And in relation to that, I think Bertrand mentioned something about vegetation, but are there any plans to go into more detail on land use or land cover in the future?
We have been exploring that, and it's something we have on the my to-do list. We are not sure about this because it's a bit complicated. And also, so we will have to look at the resources and for that. But it's something we have on the. It's not something we have to do, but it's something which is very interesting, especially both for frost and drought assessment actually. So I cannot give you a clear answer on this.
Okay, but perhaps it's something we can come back to on a later webinar as things progress.
Sure.
Yeah. Another question just for you, Oluf. Are there any plans of extending the functionality to use the data for drought and flood assessments or direct linkage to a decision process?
Yes, there are. We are currently working on a drought assessment and reporting tool, which will basically also be a web-based application which will utilize all the data in the data portal and can be used by stakeholders and decision makers to make drought assessments and drought early warning for specific areas. So, and we will do the same for floods. So there will be some flood and drought specific applications on top of this.
That was such a good answer. I think I've got another one for you before moving back to Bertrand. What is the resolution of the data? Could you say a few words about that?
Yeah, it varies a lot. Because this is a web application, then we have decided that we will not use a finer resolution than 5 kilometers. So the finest resolution we have is 5 kilometers. So some of the data actually comes in 1 kilometer resolution, then we are resampling them to 5 kilometers. So it varies from 5 kilometers and then up to around 20-25 kilometers. But most of the data around 5 by 5 kilometers, which is appropriate for basin or catchment scale assessments, but not for detailed scale assessments.
Okay, good. Thanks. Bertrand, a couple of questions for you. Is it possible to log in and register if one is not part of the project team? How can I gain access?
Yes, I will recommend to log in and to select one of the operational basin, one of the basin that is already added to the system, for example, the Volta basin or Chow Phraya or Lake Victoria basin, and access will be granted. Of course, we'll take it on case by case, but that's what I will recommend, to choose one of the basin with operational in bracket next to it, next to the name.
And I mean, there must be some kind of limit to how much data can be added to this system. Are there being any criteria applied? Is it being focused initially on certain geographies, or what's the plan there?
Yes, of course there will be a limit, and we are focusing on data that can provide value for flood and drought assessment first. So that was the criteria, and also in the way we process the data, the indices that we are providing are related to flood and drought assessment. We are trying to access data that is available globally, so we are not restricting to any region, because one of the criteria is to provide data for all transboundary basin in the globe. So we have this focus in mind.
And is the ambition to make this completely freely available? Are there going to be any restrictions or costs related to the use of the site at some point?
I think we will probably see this also as we move and depending on the needs and the different application. At least the scope is to have this portal that can be accessed by a transboundary organization and organization working in transboundary basin contexts.
Right, but if I understand you correctly, I mean, if there's a demand for greater data inputs moving forwards and further customizations, then you might need to revisit what's being planned post-project. Yes. Okay, yes. Great. Many thanks to you both. I'm afraid that's all the time we have for questions right now, but as mentioned, this is the first webinar in a series of many. Right now we have the next one scheduled on the following dates, so please mark your calendars for January the 12th to join us for the next one on drought management today, which will include contributions from HI, which is the Hydro and Agro Informatics Institute in Thailand, and also from our partners, good partners, IMI, the International Water Management Institute, and they have their headquarters in Sri Lanka, but other offices in other geographies, and do quite a lot of work in Southeast Asia. If you thank you for the many questions. I mean, we've done our best to address them here, but if you're disappointed that we didn't get round to yours, or you have any burning issues, please send an email to Maija and she'll do her best to get back to you soonest. I've already mentioned, but I'll say it again, you can get the recordings on the website here, or I think they'll be available on the yeah, we should have those up and running by Monday next week and available on the Floods and Drought Management Tool website shortly after that. We're always looking to improve the quality of our work, so we'd be very grateful if you could use a couple of minutes to respond to the feedback survey form that you're going to be receiving from us shortly. And any ideas or topics on content that you would like to suggest to us for future webinars in this series would be very, very welcome. I can see from the questions we've got some quite engaged experts out there, so please share your ideas with us. Finally, please allow me to conclude today's session by thanking the presenters for taking their time to share their knowledge with us. And I would also like to thank you, the participants, for taking the time to join us. And last but not least, please allow me to wish you all a very good morning, afternoon or evening, wherever you are.